I don't know. We'll see. Okay, so guys, first thing I want to talk about is the change of base formula. Guys, calculators out, come on. Now, on your calculator, if you guys look at your calculator, there is the log button. Everybody sees the log button. Do you see a little number to the left or to the right of the G? A little tiny base something? No. Your calculator is programmed, and if there's not a number there, it is assumed or it's understood that it's log base 10. Okay? Some of you have change of base formula in your calculator. Some of you don't. This is not a big thing that I'm going to give you 25 questions about this. But during the solving process, you need to understand how to use the change of base formula. It's really easy, guys. So if you have log base 4 of 25, the way that you would evaluate this in your calculator is log, you would hit log 25 divided by log 4. You put log of the big number, big meaning visually big, over log of the little base. So when you hit log 25 divided by log 4, what do you get? 3 decimal places. 2.322. Perfect. Good. So how would you do B in your calculator? Log 12 over log 2. What do you get? 3.585. All right, perfect. That's the change of base formula. That's what you guys got to remember. It's log of the number over log of the little base, we'll call it. That's it. Super simple. If there's not a number there, what do we assume it is? 10, okay? I want you guys to do the same thing now, but you're going to use the ln button, just so you see that ln is a logarithmic function. So you're going to take, same thing, I want you to say ln of 25 over ln of 4. And what do you get? 2.322. Is that the same thing we got up here? Okay, perfect. Same thing. Do ln of 12 and then ln of 2 divided by ln 2. Tell me. 3.585. Question. Okay, because we're talking the first, I wanted to use using common logarithms and then using the natural log, just using the 2 different buttons. Understand, guys, natural log, common log, they're both logs. It's the same thing. What is specific is that we use ln when we have a problem with e to the x, because e to the x is a specific exponential problem. You're going to use the log button anytime you have 3 to the x, 5 to the x, 12 to the x, something like that. You use ln and e when it's talking specifically about ln or e to the x. And we'll talk more about that later. All right, what we're going to talk about today is condensing. Actually, no, I want to do something else. In your calculators, everybody, what is log of negative 3? Use the negative button, not the subtraction. It says error, okay? What about if you take the natural log of negative 1? Error, all right? I need you guys to understand something. If your calculator tells you error, it could be because you input something wrong. But in a case of log and natural log, what do you think? What can you deduce from this little experiment we just did? Why are you saying imaginary? I get what you're saying. It's not imaginary, but why are you saying imaginary? I get what I understand. You're on the right track. Why is it not real? What are you taking the log and the natural log of? My 2 little examples. A negative, all right? You cannot take the log or natural log of a negative number. If you ever get a solution and you go to plug it back in, and when you plug it back in, it makes the log or natural log negative, then your answer, God bless you, would be no solution. We're not dealing with imaginaries here, God bless you. We're only dealing with real solutions, and taking the log or natural log does not exist if it's negative. So, here we go. Okay. 3 properties that are super duper important that you guys are going to have absolutely zero problem with today. We're going to talk about the product property, the quotient property, and the power property. So think about this. What does the product property probably involve? Multiplying, okay. What does the quotient property probably involve? Division, good. And what about the power property? Exponents, okay, good. So we're going to talk about condensing and, condensing. Ay, ay, ay. Hence the reason I teach the math. Condensing and expanding, okay? Let's go back to a third grade definition. What does it mean to condense? Shorten, put together. Put together. I'm going to say smush. We're going to smush them together. All right? If I say expand, what does it mean to expand something? Spread out. Okay. Pull apart. I like that. Pull apart. All right, good. All right, that's exactly what we're going to do today. That's all we're going to do. And we're going to use all of these properties tomorrow when we go to solve. But we're going to take problems that are pulled apart and we're going to smush them together. We're going to condense. Then we're going to take problems that are already condensed and we're going to pull them apart. So here are the things you have to remember. For your product property, I want you guys to look what happens here. When you are multiplying two things together, do you see how those are already smushed together? There's only one word log and it's smushed together. When we pull it apart, what does multiplication become? Addition. Very good. All right. Both cases occur if you have natural log or regular log. But if you are already smushed together, when you pull it apart, multiplication becomes addition. All right. So let's look at the next one. When I have division, it's already smushed together. When I pull it apart, what does division become? Subtraction. Good. And then the last one, if I have an exponent, so I kind of talked about this yesterday for a second. I was getting ahead of myself. I understand that. But what does the exponent become? The number in front, the coefficient. So just the opposite, guys. If you're already pulled apart, if you start off with addition and you smush it together, what does addition become? Multiplication. If you start off with subtraction and you smush it together, what does... Good. And then if you start off with a coefficient, it becomes your exponent. Very good. Now that's it. That's all you need to know for today. That's all we're going to do is practice pulling it apart, smushing it together. You remember those three things. Don't worry about that. I'm going to take that off. If it's on WebAssign, we'll take it off. We don't need to do that. I need you guys to get to the properties. Don't worry about A and B. Yeah, let me do one and then you'll see, okay? Now, we're going to do a few examples here. Look, it's going to say condense or expand. It's not going to tell you exactly what to do. You guys need to recognize what's happening, what you're starting off with. If I look at A, is A written all smushed together with one word log, or is it written all pulled apart and everything has its own word log? It's smushed together. This is already smushed together. So I'm going to rewrite this. I'm going to say log base 4 of 5 x cubed and y. What is happening in between the 5, the x cubed, and the y? I'm going to rewrite it like this because a lot of times when you guys have a coefficient, you forget. You forget that those two things are separate. So what I do, especially when I'm making your answer keys and stuff like that, I look at what I'm starting with and I say, okay, I see 3 multiplications. What else do you guys see? I see an exponent, okay? You can do everything all in one step. I don't think it's the best idea, but you guys can if you want to. I'm going to just pull apart. So everything has its own log. So I'm going to rewrite this as log little 4 of 5. What does multiplication become? Addition. So log little 4 of x cubed. And then I have another plus sign, right? So log little 4 of y. Everybody with me? Okay, so everything's linear except for one thing. I have this exponent. What does this exponent need to become? It needs to come right here. I need to write it right there. So I'm going to rewrite this as log 4 of 5. My exponent becomes a coefficient, so plus 3 log 4 of x plus log 4 of y. And there is your answer. Question. No? Okay. Everybody all right? Okay, so now let's look at the next one. I have B. B says the square, whoops, ln, right? And then the square root of 3x minus 5 over 7. Side note, we'll talk about we'll talk about this as we go, but what do you guys see? Okay, I see a division right here. And I see a square root. Good, I'm glad you said that, Alec. I see a square root. Because what's another way that we could write a square root sign? A fractional exponent. A fractional exponent. So when you guys have a root, whether it's square root, cube root, fourth root, something like that, rewrite it. So this is really ln of 3x minus 5 to what power? To the 1/2 over 7. If it was the cube root, it would be to what power? The 1/3. If it was to the 8th root, it would be to what power? 1/8, okay? But always rewrite that because that actually is an exponent. It's going to become a what? Coefficient. Okay, so when we pull everything apart, all right, everything gets its own natural log now. So I'm going to write ln of 3x minus 5 to the 1/2. Some of you are like, can I just put the 1/2 in front? Yes, I'm just not going to do it right now. And then what sign comes since I have division right there? Good. Minus ln of 7. Now I have one more little step. What can I do? Take this 1/2 and it goes boop right here in front. So I have 1/2 ln 3x minus 5 minus ln of 7. Some of you might be like, oh, this is pretty easy. Some of you are like, huh? And that's okay. We're going to practice it. That's why I gave you guys a few days to do this. But we're going to apply these properties tomorrow when we start to solve. All right, how we feel? All right, let's look at the next group. I got 3 more examples. Now, looking at this, again, your test is going to say expand or condense. I'm not going to tell you what to do. You have to realize what to do. Is this already pulled apart and we need to smush it back together? Yes. Okay. So in letter A, I'm just going to look for a second. I see a few things. I see a 1/2, which would become a what? Exponent. I see a 3 out in front, which would become a what? Good. And then I see a plus sign, which becomes what? It's good to kind of give yourself a little talk through everything. Do you see that both of these are the same log base? Yeah? So how many times do we write it? One time. I'm going to write it one time out in front. Do I have to write the little 10? No. You can, but you don't have to. No, you don't have to. Good question. So watch. I'm going to say this becomes x to the 1/2, right? Then what? Times what? X plus 1 cubed. Guys, you do not have to write x plus 1 times x plus 1 times x plus 1 and multiply it out. You don't have to. But I can simplify this just a little bit. How could I simplify this a little bit? Okay, I understand. That's a good thought. I guess if you wanted to, you could, but you don't have to. And you can leave it just like that. You do not have to FOIL. You don't have to combine. No. Don't. Yes, sir.
Do you want us to square root the x if we have it 1/2 is the exponent?
Yes. Don't leave exponents in there that are fractional. Good question. All right, let's look at B. Kind of survey what you have here. I have a 2 out in front. That's going to become a what? Okay. I have a minus sign. That's going to become what? Okay, perfect. Do you have both the same log? Yep, they're both natural log. How many times do we write it? One time. Stick it out in front. I know this is a division problem. Don't stick the natural log in the numerator. Put it out in front. So this is going to become x plus 2 squared. What? Divided by x. And leave it just like that. Those x's don't cancel. That x plus 2 is stuck together with a plus sign. You cannot just go, oh, cross it out. No. Doesn't work like that. You just leave it just like that. All right, letter C is a little more involved. Nothing at all you guys can't handle. Let's look through it. I see a 1/3. Where is this 1/3? It's on the outside. This is on the whole thing. So at the end, what are you going to have? A cube root over the whole thing. Okay, so good. Look inside your bracket. Do you have any coefficients that are going to become exponents? Okay, good. You just have a plus sign that's going to become what? Do you have the same log base? Okay, so let's go. I'm going to do this in a couple steps here. I'm going to say this is log base 2 of x times x minus 4, and it's raised to the 1/3 power, correct? All right, I have one more thing I have to do. Keep your log base 2. That is outside. That is not underneath the radical. Underneath your radical, you have the cube root of what? X times x minus 4. The log stays outside. Everybody see that?
We're not gonna have different log bases.
No, you won't be able. You'd have to only use a calculator for that. You'll have different log bases possibly when you're solving, but that's just at the end, like you do a change of base, whatever. You'll be fine. All right, are we okay? All right, that's it for today.